Okay, in the previous discussion, we quickly glanced through the integration here, and we found out the value of x bar, and we also discussed in detail the concept of this equation given here, and we analyzed that. We analyzed this equation f of x is equal to b into 1 minus x square by l square, and we found that the rod is denser at end A and is rarer or lighter at end B, which means along the length AB, along the length x equal to 0 to x equal to L, the mass distribution varies from maximum mass per length to minimum mass per length, and since we have x square by L square, we have a quadratic reduction of mass from A to B, right? And we also discussed that the center of mass is closer towards the denser side and is far away from the lighter side, which marks the concept of tapering beams. Since that we have discussed the concept in detail, let us now focus on the mathematical part of this, the integration part. So lambda x is replaced by f of x here. So lambda x is equal to lambda 0 becomes f of x is equal to lambda 0 is replaced by v, so it becomes b into 1 minus x square by l square. Okay. Now why? Just because for convenience. So x bar, right? So we have x bar, which is equal to the x coordinate of center of mass, is given by integral of 0 to L x f of x dx by integral 0 to L f of x dx. Now this actually corresponds to the equation x bar is equal to sigma mi xi by sigma mi. What is sigma mi means, or what is 0 to integral f of x dx means? This denominator here represents the total mass of the rod, that is m. And what does the numerator represents? The numerator represents the mass moments. Numerator represents the mass moments, which is given by sum of individual masses into the distance they are placed within the mass. Okay, so let's now try to understand the integration of the numerator part here, which is 0 to integral x f of x. So very straightforward integration actually. What is f of x? It is b into 1 minus x square by l square. So when you have x into b into 1 minus x square by l square, okay, before we go into the integration, some of us may have a doubt regarding the limit 0 to L. Now how do you understand that? For that, we have to come back to our diagram, which is here. So when we say that the linear mass density is a function of x, linear mass density is a function of x. So we have linear mass density is a function of x, which means linear mass density will have its lower limit, at the lower limit of length, which is x equal to 0. And linear density will have its upper limit when the x is at the distance is at the maximum limit. So lower limit is at x equal to 0, correspondingly upper limit is at x equal to L. Very simple stuff. I hope that makes sense. Okay, so the limit here becomes 0 to L. So x into 1 becomes x into x square becomes x cube. Since b is a constant, I take that out of the integrand here. So what we have here further is b into integral x dx minus integral x cube by L square dx. L square is a constant here. Why? Because here L represents the length of the rod, which is a constant, right? Length of the rod is a constant. So b into integral of x is x square by 2, varying from 0 to L. L is a constant, so we have 1 by L square outside the integrand. It becomes 1 by L square into integral of x cube is x to the power 4 by 4, varying from 0 to L. Then x to the power L by 2, varying from 0 to L, becomes L square by 2 minus 0 square by 2. X to the power 4 becomes L to the power 4 minus 0 by 4, which gives us L square by 2 minus L to the power 4 by, okay, so we have L raised to 4 by L raised to 2 is equal to L raised to 2 by 4, which is 2L square by 4 minus L square by 4, which gives us b into L square by 4. So x bar, or the x coordinate of center of mass, is integral 0 to L x f of x dx by integral 0 to L f of x dx. We have so far integrated the evaluated the numerator, which is equal to bl square by 4. Now let us focus on the denominator. So denominator again is a very straightforward integration. F of x is b into 1 minus x square by L square dx. B is a constant, can be taken out of the integrand. So that becomes b into integral 0 to L 1 minus x square by L square dx. This integrand can be split into two halves. Integral 0 to L 1 dx minus integral 0 to L x square by L square dx, which gives us b into integral of 1 is x, varying from 0 to L. X square is x cubed by 3, varying from 0 to L. L is a constant, so I'll take it out of the integrand, 1 by L square. Then what we get is, applying the limits, x becomes L minus 0, L cubed by 3 minus 0 cubed by 3. That becomes L minus L by 3, which is equal to 2L by 3. So that becomes 2LB by 3. Now we have found out both the numerator and the denominator. That becomes BL square by 4 by 2BL by 3, which is BL square by 4 into 3 by 2BL. Now let me just confirm this. So B by B is 1, L square by L is L, 4 into 2 is 8, so we get 3L by 8. And according to the question, the mass density is, sorry, the center of mass is 3L by alpha m, right? So distance of center of mass from end A is actually the x coordinate of the center of mass, which becomes 3L by alpha. Now comparing these two, we have alpha is equal to 8. Okay, so we did discuss in detail the significance of this equation and the derivation for the same. So maybe I'll just leave out this for you to take it down. So although this is a very simple integration, I would definitely suggest that you take down things with me for one time, practice it a couple of times, and then speed comes naturally to you. Speed in solving the problems. Okay, now moving on to the next question, which is based on semicircular ring. Okay, center of mass of a semicircular ring.